Good, okay, question 3. No, that's the wrong one. A trapeze thing, theatre company needs to employ 3 technicians for a performance. One operates the lights, one the sound system, one the flying trapeze. 4 people applied for the task. Aha! At that point you should realise one person will have to not be employed. The theatre company wants to employ the 3 technicians for which the total cost is least. Great. Well, that's okay because Hungarian algorithm finds the least cost allocation. So we're wanting to find the least cost allocation out of that. So there's none of that taking everything away from the biggest number kind of thing that we need to do. We're all right with that bit to start with. But this can't be done before you modify the table. Right. Modifying the table is, we've got 4 people and only 3 jobs. So we need a dummy job to make sure that one person is not employed. So we need to put in our 4th column. I'll call it X, you can call it whatever you want. And that needs to be at least as big as the biggest number in the table. So that is going to be 100. A couple of you used 110 because you used the biggest number and added 10 on. That's absolutely fine as well. You can use any number you like as long as it is greater than or equal to the biggest number in the table. At least one person got really carried away and saw there's a blank column and a blank row. So they created a blank column as a dummy activity and then an extra blank person as a dummy person. But that ended up with the same problem that we started with having too many people for the number of jobs.
They just gave you an extra row.
They gave you an extra column and an extra row because they didn't want to lead you into... If they'd just given you the extra column, it would have been obvious, wouldn't it? That you had to fill in the extra column. That's why they did that. Right, then it says... Working from your modified table. Now again, we've already talked in this paper about reading the question. The question was very, very specific about how you should do things. So construct a reduced cost matrix by first reducing rows, then reducing columns. Now read on, it then says you should show the amount by which each row has been reduced in the row reductions and the amount by which each column has been reduced in the column reductions. I've not seen that before. It's not a big deal. We don't normally write that information, but they have explicitly asked for it, so we have to give it. Okay, we can't just ignore that bit in the question. There is going to be 2 marks for doing that broadly. Cross through the zeros in your reduced cost matrix using the least possible number of horizontal or vertical lines. You must ensure that the values in your table can still be read. 5 marks, that's quite a lot to do just on this kind of one little bit of instruction. So, we need to reduce the rows first. It said reduce the rows first. You subtract the smallest number in each row. So this row, I'm going to take away 86. That gives me my new top row. This row, I'm going to take away 92. This row, I'm going to take away 88. And the bottom row I'm taking away 98. And there we go, that's my reducing the rows. Now we need to reduce the columns. I'm going to take away 0. I could probably get away with not writing that. I'm going to take away 2. And I'm going to take away 0. And I'm going to take away 2. Bear in mind that if you had done that as being 110, for example, at this point you're taking away 12. That's fine. Take away 2. And that's the table that we end up with. Okay? Those who didn't write these numbers lost a mark in doing that because the question asked you to write those numbers. Then it says use the horizontal and vertical lines. The least number possible. We know this as well, don't we? That when you're doing this bit, you need to do your lines so that they take out as many zeros at once. I think there we go. We've got 3 lines. It's a 4 by 4 matrix, so that means it needs to be augmented. And part 2 says complete the application of the Hungarian algorithm. So we're going to take this now and complete it. Our value of E, I need to see both on the same page. You did have both of them on a single sheet, didn't you? So you could look at that quite easily. Our value of E at this point, and it didn't ask you for it, but I would write it down, is 3. That's the smallest uncovered element. So we take 3 away from every uncovered thing. We leave everything that's covered once as it is. We add 3 to everything that's covered twice. So that's going to give us a new matrix of 0, 0, 1, 9, 0, 0, 0, 3, 0, 2, 3, and 7, and then that would be 3, 3, 0, 0. There's our new matrix. That was X, wasn't it? And then remember, you do that thing where that would need 4 lines, so now we just look at where we can do it. The easiest way to do it is to think, as we look through this, that must be in play because that's the only 0 in that column. That's the only 0 in that row. If we've taken out that 0, then that remains the only 0 in that row, and that one has to be used because that, if there's already a 0 in that row, then that's the only one in that column. Does that make sense? There we go, that's our solution. So that is, what is that? Amir is doing the sound. Bex is doing the trapeze. Was it Kaz? Kaz is doing the lights. And Paul D is doing nothing, because that was what the final column related to. These, in the original table, that was 88, that was 95, that was 88 as well, giving us a total of 271. Of course, we don't add on the 100 that we allocated for him doing nothing, because you're not going to pay D £100 for doing nothing. That doesn't make any sense. So there we go, 271. Then it says, although I may have put in the lowest cost for operating the lighting, you should have found that he has not been allocated this task. We did. Amir is particularly keen to be employed to operate the lights, so is prepared to reduce his cost for the task. Find a way to use 2 of Beck's cousin D to operate the sound effects and flying trapeze at the lowest cost. This was just a case of looking at the original table, looking at those values. It's quite clear from the original table that if we're restricting, there it is, if we're restricting, well, we're looking at that bit, aren't we, there? And we want 2 out of them. Well, you could do 94 and 94, but 95 and 92 is better. That's slightly less than 94 and 94, isn't it? So 1. So that's going to be the way to do it. We are going to have Kaz is going to do the sound for £92, and Bex is going to do the trapeze for £94. So between them they add up to 187, and we're supposed to come in £1 cheaper than they were before. So we now need to work out what we need to add on to get that. So 270, that's 271, take away the £1 cheaper that we're going to be. Take away 187, 270 take away 187 gives us 83, doesn't it?
Please, it's 95.
It's 95. Oh yeah, I've just written the wrong number, haven't I? Which was it? It was 95. I've got 95 on my sheet, don't know why I've got 94. Da-da. That's 83 that comes out with. £83 is what Amir should charge. Okay. Be really careful. There was some kind of illogical things going on in here. Like somebody worked out the total to give £1 more than it had been before, instead of £1 less.
But I also don't know the numbers anyway, so you
I think there was somebody else as well, actually, John, as well.
I knew it was wrong. Right. There's no point scribbling out that point, was there?
That's allocation maths with a trapeze.